Good afternoon or good morning, wherever you're watching from. So on with the agenda, and we have two fabulous speakers up next, Ryan and Eltjo. Eltjo is bringing some amazing colour to your day. Great background there. So they're going to be talking about what the real experience is like from a cloud workspace. Packed session, so I'm going to shut up talking and hand it over to you guys.
Thank you very much, Neil. Good afternoon, everyone, and welcome for joining our session into this virtual UK Citrix User Group Summer 2020 meeting. My name is Eltjo van Gulik, and with me on the air is my partner in crime, Ryan Ververs-Bijkerk. We are from GoEUC, and in the next 30 minutes, we're going to tell you everything you ever wanted to know and more on the real user experience from a cloud workspace. The last time we were in the UK, was actually back in January when we had a layover in Manchester Airport when we were flying through Orlando for Citrix Summit. And we spent about 1.5 hours on your lovely airport. Must admit, wasn't the most exciting place to be, wasn't the most British place to be. I mean, there was no tea, there were no crumpets, there was no fish and chips, but there was a lot of queuing though. Before we start, I have a small warning. It's up here on the screen as well. We have a lot of data for you guys to present, and we only have 30 minutes. People often tell me that I talk way too fast, and on this occasion, it will probably not be any different. On the other hand, you are accustomed to Jim Moyle, and he talks very fast as well. And the other positive thing about the virtual meeting is that they are going to record this session, and you will have the option to play it back at 75% of the speed afterwards. So, all jokes aside, my name is Eltjo van Gulik, and in contrast to Jim Moy, I did not cut my hair. I am from the Netherlands, as you might have guessed by my accent and my pronunciation, and I am a workspace consultant for a Dutch company called ICT Partners. I work there as a workspace consultant. Furthermore, I'm a Citrix CTP, and I recently joined Team RGE as a new community member. Did you know, by the way, that prior to the COVID-19 situation, I had short hair and a goatee?
Interesting fact, Eltjo. So my name is Ryan Ververs-Bijkerk. I'm a technical evangelist at Wallworks, where we focus on mission one, which is making the workspace intelligent using modern technologies like the micro app solutions from Citrix, but also a lot of automations and AI. I'm also active within the community, part of the Team RGE team, and doing a lot of stuff for GoEUC. So today, agenda. First, we're going to start with an introduction about the GoEUC platform. Then we're going to dive into the benefits of using optimizations within the cloud. Then we want to briefly touch on the cloud scalability. And at the end, we're going to end off with the real end user experience, and the interesting part. But let's start with the GoEUC platform. Now, GoEUC is an independent platform where we focus on performance-related topics, anything EUC related. And there's a famous quote of Neil Armstrong stating, "Research is creating new knowledge." And we really believe in this statement, because when doing research, it gains knowledge which we can use and benefit in our day-to-day job. So our mission of GoEUC is to facilitate the individual with these research capabilities and also the methodologies that we have. And this allows you for exploring these new technologies. And we really hope that we inspire you, you and the community, by providing this new knowledge. So this is for us really our mission for GoEUC, where we stand for. A little bit of a background of GoEUC. We started back in September 2018, but since April this year, we did a big transformation towards a non-profit foundation. This means that we are fully independent and unbiased, and it's really an initiative that is created by the community for the community. So everybody that's involved, which are currently 11 members, are on a personal basis involved within the platform. Now, in order to keep this up and running, we have to get some money from a sponsor. So in this case, we have two active sponsors, LoadGen, which is a load simulation solution, and the employer of Eltjo, ICT Partners, that are backing up this initiative and make sure that we can keep running. Now, everything that we do, we publish on our website, which is go-euc.com. And it's an open website. It's in a blog format, and we publish all our researches on the website itself. So there's no registration required, and hopefully it's also easy to consume and easy to read. If not, please let us know. Then we have to improve the writing style, of course. Now, a little bit about our testing methodology. So in this case, we use LoadGen as our primary load simulation solution. So LoadGen allows us to virtualize or simulate user behavior on the environment by using workloads. Now, we use this in combination with Rex Analytics. Rex Analytics is the solution I think also Rode uses in his research, which is also really focusing on getting the user experience recordings. I have to state that we hacked Rex Analytics a little bit, so we're not using the full implementation of Rex, but I still want to provide the credits towards Benny's solution. Now, for all the scenarios we're going to present today, we have used the following configuration. So represented on the right side, we have the customer side, which basically is just at my home. But there we have a client which is connected via a dedicated capture card towards a machine. So this allows us to grab the output from the machine and record all the user experience without interfering the performance of the endpoint itself. Now, when we remote in, we remote through our GoEUC platform. Now, in this case, it's still hosted at OVH, which is a service provider, and we selected the location Germany. So here we have our basic components running that's required in order to do performance testing. Now, in order to do cloud scenarios, we have decided to implement the most easy way for the cloud, which is a hybrid scenario. So we use the site-to-site VPN in order to connect towards the cloud, where we only host in the cloud connector in order to communicate with Citrix Cloud and the VMs itself. So these are the VMs where the workload will be executed. Now, everything that we do is fully automated, so there's no human interaction involved. And also the results we're going to publish today are consist of multiple cycles. So everything that we publish is are averages of those runs. Now, to ensure everything is idle and stable, we always produce the cycle that's shown on the left side to make sure the environment is ready to go and consistent, so we can reproduce consistent results. Now, from the sources perspective, the data sources, we use multiple data sources. So in case of LoadGen, we have the ability to collect application data. We also have Perfmon for the VM data. So this is the VM that's running within Azure. We can also use that for the launcher. So this represents the endpoint. And at the end, a very important factor, we have protocol data using remote display analyzer. So this allows us to provide an image or from multiple angles to tell at least the complete story. So it's a quite quick introduction. So let's go to the first topic. Eltjo.
Thank you very much, Ryan, for the introduction. Ryan and I do a lot of VDI projects, and what all those projects have in common is that the user experience and the performance almost always go hand in hand. And towards that end, I did a small I did a small poll on Twitter a while back where I asked what you guys, the community, thought was the most important factor when considering a new VDI or DAS solution. And not surprising, you guys chose the performance as the key factor in that. That doesn't mean we should rule out the other factors like security and availability, especially with the whole working from home situation with COVID-19 going on. Those are equally important, but you guys valued performance most of all. And that's good because that is right up our alley. One of the most important things when it comes to performance is to optimize or tune your image. And where in the past we did it all manually, I had a lot of scripts lying around that I used. Nowadays, it's much easier to do it automated with tools like VMware OSOT or Citrix Optimizer. In the next couple of minutes, we're going to show you what benefits you can reap by optimizing your image. And for that, we came up with the following scenario. We took a fairly standard Azure machine, in this case a D4 V2 machine that is 8 vCPUs and 28 gigabytes of memory, installed with Windows 10 1909, Enterprise Multi-Session, the latest LTSR VDA, and Office 2016. We took two scenarios. The first one, represented in blue, is our baseline scenario. And in this scenario, we took an image. I wanted to say the next finish image, but I really hope that you guys, just like us, automate your golden image management. So let's say the image, how it's rolled out from your CI/CD pipeline. In orange, we got the same image, but afterwards we've optimized that with Citrix Optimizer with the 1909 template, and we selected all the default optimizations. That is the optimization of built-in apps, scheduled tasks, services, and what have you. So if we dive straight into the data and look what we collected, from the start it is apparent that optimizing the image has a hugely positive effect on the CPU usage and therefore the overall performance of the VMs. We can see a large reduction in CPU usage. The same goes for the storage metrics. We can see a reduction on storage loads for both read and write operations. But that's all nice and well. Well, what is the first time that a user will notice when they log on to the VDI? Right, exactly, the logon performance. How long does it take for them to get logged onto the desktop? And it's also the first time that they can really evaluate the performance of the VDI. So it better make sure that they get the fastest logon time possible, right? Well, here we can see that optimizing your image just does just that. With optimization, we can see that the logons are almost 20% faster than an unoptimized scenario.
So it's important note to state here that in this fact, it was the without optimizations in 28 seconds and with optimizations in 22 seconds.
22 seconds, yeah, pretty fast, I reckon. If we make stuff a little bit more interesting and extrapolate our data to, let's say, 1,000 users, we can clearly see that the optimized scenario has a much better scalability. And that means that we don't need 55 VMs to host our 1,000 users, but in this case, we only need 32 VMs to get all those people up and running. As you all know, Azure and all the other cloud offerings like AWS or Google Cloud Platform are pay-per-use. And because we need less VMs this time to host all the users, that means we can save money. And in our particular frame of reference, being the D4 V2 machine, our workload and 1,000 users, we could have saved around 4,500 euros. And that's roughly 4,000 pounds on compute cost alone in Azure. And for us being Dutch, that's truly magnificent because we really like saving money. Do bear in mind that the statistics that we just show you are only the compute costs. We did not take the cost for storage and network into account. So in summary, with this research, we wanted to show you what the benefits were of optimizing your VDI imaging. I reckon we did a pretty good job on that. We showed that optimization is always the best practice, not only in on-premise workloads, but especially in cloud platforms. Cloud platforms like AWS, Azure, and Google, because for these platforms, we can realize significant cost savings by optimizing, therefore reducing the amount of VMs that we need to host all the users. In our scenario, we could have saved $6,400, which is euros, which is roughly 4,200 pounds a month. And that is, I think, pretty huge. But optimizing isn't the only part of the equation. You should always choose your right size for your workload, especially in Azure. And by sheer coincidence, that is also the next subject on our agenda. Ryan?
Oh, what a coincidence.
Yeah.
Thank you, Eltjo. So let's talk about cloud scalability. So when walking in a pub and talking to a girl, oh no, wait, sorry, that's a different story. When moving towards the cloud, a lot of people state like there's infinite resources, so size doesn't matter. But where we experienced in the last couple of months with the whole entire COVID-19 situation, we have seen that even though in the cloud there's limited resources, where everybody's of course moving towards the cloud right now. There's a couple things that are really important when you moving towards the clouds, especially when in a multi-session scenario. Yeah, you have the scale up and the scale out scenarios. When they do scaling up, this means that you're including more users on a single box, and scale out means that you will use more machines. So with that scenario in mind, we have decided to research the following scenario. So it's similar towards the previous one, where we have selected just the Windows 10 1909 multi-session edition using the 1912 RTSR VDA with just an Office installation in 2016. And like we have learned from Eltjo's part, we applied the Citrix optimizer template as the best practices. So on the right side, we have selected the following scenarios. In this case, these are all the D2 series or the D series. So represented in the blue, we got the D2 V2, which contains 2 vCPUs and 7 gigs of memory. In orange, we have the D3 variant, which contains 4 vCPUs and 14 gigs of memory. In gray, the D4 with 8 vCPUs and 28 gigs of memory. And at last, which is a big one, which you can also see to the estimated cost, it's the D5, which has 16 vCPUs and 56 gigs of memory. So when you look at the user density, and we have determined this based on the CPU utilization, including with load gem, we have the following numbers. And this is really as expected. When you have more resources available, you can host more users on a machine. Now, when we convert this towards a scenario where you have to host for 1,000 users, this also makes sense. When you have a smaller VM which can facilitate less users, you will need more VMs. So in case of the D2 variant, we need 200 machines. Now, in terms of draining the environment, when you want to reduce the cost by auto-scaling, it's important to take this account. When you have a bigger machine, it's harder to drain the users from that machine. And I think we even learned that from, at least I learned that from Jim during the E2E presentations, that these percentages you have to turn off the machines or drain the users, it's rapidly growing quite high. It was for me at least really an eye-opener. Now again, looking at the compute cost, it's important to take the cost into account. And here we can see a big jump from the D4 variant compared to the D5. So in this case, we as Dutch, we prefer, of course, the D4 variant as is the lowest. Now to wrap up this research, I think it's really important to understand the workload, and based on the workload, choose your correct the VM size. And you have to take into account the balance between the scaling up, scaling out. It's always difficult, at least, to drain the machines. And when you can turn off resources within the cloud, it saves money. In this case, for us, we have seen that the D4 is the sweet spot in terms of cost and also in our terms of scalability. And it's always important to leverage this auto-scaling technology and shut down the unused resources to reduce the cost. So let's go to the next topic.
Okay, thank you very much, Ryan. We're going to switch gears a little bit and move on to the last topic, and in my eyes, the most exciting one, the real user experience. So over the last couple of years, there's been a steady increase in virtual GPU usage in VDI environments. And nowadays, it's very common to add a vGPU to a workload, not only on-prem, but also in the cloud. And in the past, there was only one major playing in the field, and that was actually NVIDIA. But nowadays, Intel and AMD really stepped up their game with their Fire Pro and Iris Pro and Fire Pro offerings. The latter ones even being available in Azure these days. And if we look at the application landscape for VDIs, we can see a big shift. Where in the past, vGPUs were actually only used for very specific workloads like CAD/CAM and stuff for Autodesk. But these days, actually all applications can benefit from adding a GPU, whether it's Office, all modern browsers, or even Windows itself can benefit largely. And if we look at a typical VDI project, there we go. After a couple of months of blood, sweat, and tears, hard work, and the VDI team finally delivered the VDI to the end users. But the end users, they're struggling. They're frustrated because they aren't getting the experience that they expected. So they phone up support. Well, support being support, they hand the problem back to the VDI team. The VDI team goes to check and says, well, it works on my machine. And there you have the whole root of the problem. It works on my machine. How many project teams have you seen that use old thin clients? I certainly haven't. Most of them use state-of-the-art laptops. And then this is exactly the same conversation I have with every customer. We have GPUs in our environment. Why isn't it performing? Well, did you take a look at the endpoints? So before we carry on, we would like to thank the thin client specialists in Eltjo, because prior to this research, they delivered 2 huge boxes full of endpoints to my doorstep. And from that selection, from that whole box, we made a small selection from thin clients for you guys to show and to test today. For instance, we got 2 Eltjo UD3s, we got a new one and we got an older one. And right at the back, we got an older Dell Wise D7 thin client. That's a real golden oldie. But there's one thin client that especially stands out, and that is one PC that doesn't really see that much underneath a desk in a typical office. Is that right, Ryan?
Yeah, I'm actually you stating that it's a thin client, but it isn't. It's my game PC.
And it's a very huge one, to be exact.
Compared to the others, it is. Yeah.
Yeah. So that's Ryan's game PC, and it costs over twice as much as the other thin clients, or the other PCs. Mustn't call it a thin client. And we came up with the following scenario. We took a Azure machine again, but this time we took an MV6 machine. We took the Pro machine. Why? Again, we are Dutch, we're cheapskates, so we took the Pro one because it's cheaper. It's quite a beefy machine. It's got 6 vCPUs, 65 gigabytes of memory, and it uses a Tesla MC60 card. Again, just like all the other researchers, we're using Windows 10 1909, Office 2016, the 1912 VDA, and we optimized the image with Citrix Optimizer. One thing to note that's a little different than our previous researches, we are running single user tests. And we're using a custom workload, but more on that later. We did also set a couple of Citrix policies. The most important one, and you'll see why later, is the target frame rate. Normally, it's kept at default at 30 FPS, but really up the antes, and we put it all the way up to 60 FPS. So, what we did is we are going to show you guys a couple of videos, and we have a current screen layout. So in the top right, in the light blue, we got, for instance, the new Eltjo UD3. The top row, we got the green ones, Ryan's game PC, and right underneath Ryan's game PC is the older Dell Wise D7. So we took a workload, a typical task workload, and that is a data entry workload. And as we can see in the next video, which should start right about now, it's not very exciting. It's just a typical workload where there's some data entry in Word. Nothing much going on there. And if we took the data, we can see the same thing. It isn't that interesting. There's not much going on with the data. CPU usage, really, really low, just like we've seen in the video. Same goes for the GPU usage, which is pretty low, which is not that strange, right? There are not much screen updates, so there's not much to send over to the client, so the GPU doesn't have to work too hard. And we can see that reflected in the frames per second as well. It's all very, very low, not averaging anywhere above 12 FPS. Things get a little bit more interesting when we go into the next workload, which features a PowerPoint presentation.
So when looking at the PowerPoint presentation, at first sight, you slightly see the difference, especially in the D7 one. So it's the dark blue representative. And when it goes towards the animation, so it's currently at the ICTR introduction, and that was the older name.
Yep.
Here you have the introduction of the new name. Here you can really see it's struggling with showing the animation on the D7 client. So when looking at the data, oh, what a nice timing to switch, we can see that the machine is not really utilized. And this makes sense, right? We only have one single user on the machine, which is an NV6 machine, is really beefed up. So when looking at the GPU utilization, we can see a little bit more utilization in there. So you compare towards the office scenario, it's clear that Microsoft or the PowerPoint can leverage the GPU. But again, there's more than enough resources. This is an interesting part. And for me, this was really an eye-opener. So when looking at the frames per second, you can still see here that the D7 is performing equally compared to the rest, where we clearly see in the video that is struggling behind. So although the results stated that is the same, the video proved us that it's the experience not that great. So for us, it was really an eye-opener where it's important to look at the experience of the endpoint and not only look at the data. So let's go to a more interesting one. Let's go to the car visualizer. So in this case, we have selected the 4 machines. In this case, two best performing machines, which was the new UD3 client, and of course, luckily, my game PC. And we have the older UD3 client represented on the left bottom, and on the right bottom we have the Dell D7. And as you also can hear, the audio stream is not really consistent. And this shows that an endpoint can really make or break the user experience also from both visually and from the data itself or the audio stream. So looking at the data, we can still see that the CPU utilization is quite low. And we got enough resources. And you already start seeing a difference here on the GPU utilization, as the older or the not well performing clients cannot really utilize the resources. I'm sorry, I have to go a little bit quick because we're running out of time. So comparing in a percentage, you can clearly see that the Dell D7 is struggling behind and not leveraging all the resources. And this also applies for the frame buffer. Now looking at the frames per second, luckily you can really see a difference here between the different scenarios, especially for the D7, as the experience is not that great. And that shows that there's more than a 50% difference between compared to the great performing machines. So the new UD3 and luckily my game PC.
So on to the second to last video at this time, and that is a video we all know and love. It's Big Buck Bunny, and we chose this video because it's pretty intensive. It is a 60 FPS Full HD video, and right from the start we can see in the bottom right that the Dell Wise D7 is really struggling. And if you skip on to the next video, we can also see what's happening in the end, because in the end, while all videos are already done, the D7 is trying to compress all the sound of the last couple of minutes into a couple of seconds.
So should play really the next video.
Yeah. Here we go.
How to queue for the next one.
Queue for the next video.
Oh, okay. Then we got a difficulty. Let's go to the slides then.
Never mind. Let's go to the data. Go. Kind of got off guard there. As we can see, this is a lot more CPU intensive, and bear in mind that this is a single user test, and this video uses almost 20% of CPU usage over the whole line for one single user, which is used. Same goes for the GPU utilization. GPU utilization for one user is actually pretty high, with tops averaging around 50–60%. If we look at the GPU utilization, we can see that there's not much different between the 4 thin clients that we used, all pretty much equal. Frame buffer usage, funny thing happening there. The frame buffer usage for the Dell D7 in blue is taking a lot longer than the other ones. And that's because it's really falling behind in playing the video. Yeah, we can see the same thing in the frame buffer. It uses much more frame buffer because it needs a lot more time to display the whole entirety of the video. Frames per second, and here you can clearly see why we set the frames per second to 60 instead of 30, because the Dell UD3 and Ryan's game PC are able to leverage the 60 FPS without a problem, while the other two are clearly struggling to deliver that much amount of frames to the end user. We can see that in percentages as well. The Dell Wise D7 is only able to deliver 74% of all the frames to the end user, which is a horrible experience. So an endpoint can make or break the AE experience, and be very mindful of what your workload is. As we saw in the first part of the workload for the Word video, it wasn't that intensive and all the thin clients could cope just fine. But the other ones, we could clearly see that all the thin clients are really struggling. If you add a GPU to your VDI, make sure that your endpoint can handle it and can decode the screen at the back end again. And why invest in a GPU if you don't invest in thin clients? So we got a couple of key takeaways for you. You can save money by applying the right optimizations, especially in the cloud where you have to pay per use. In our case, the D2 V4 machine in the D series was the sweet spot in terms of scalability and cost, but it's always important to make sure that you understand your workload and use the correct endpoint, as it can really make or break the experience. We would like to end with the famous quote from Edward Deming: "Without data, you're just another person with an opinion." And as history taught us, all good stories should end with a moral. And at that point, you should always check the data yourself, especially what we told you. Remember that I told you in the intro that I had short hair before we started the whole COVID thing? Well, that is a blatant lie. I have had this hairdo for over a decade, and I think I was born with a beard. So, on that bombshell, thank you very much for watching. Enjoy the other sessions, and we hope to see you guys at the next UK meeting, hopefully face to face.
With a pint.
We will probably. Yeah, awesome.
Cool, guys. Thank you very much.
No problem.
Great session there. We've got a few questions that are coming online, so I'm just going to run through them quickly as we're running a little bit, but we have a break next, so we do have a bit of buffer time. So which type of disks were used for the Azure D4 V2 images? Was it premium or standard SSDs or hard disk drives? It's standard SSD, as the premium are not supported in this particular machine. Okay. And let's have a look. Where can I find more information on the stuff you presented today? Continue, Eltjo. Yep, sure, I take that one. All the data and all the things we shown here at the in these sessions, all published on the website. Just as Ryan said in the intro, you can find everything open on our website, site www.go-euc.com. Okay. And presumably you can sign up there to get like notifications when you publish new research and things. Exactly. Lovely. Well, fantastic, guys. Thank you very much for your time. As I said, please, if you're watching, submit your feedback at the top of the page for each session. You will get bonus points on the leaderboard and hopefully send you on the way to getting that £100 Amazon voucher. So we've got a short break now. I think we'll resume back in 10 minutes. So do join us for the next session. Thank you very much. Thank you, guys.